Okay, I just wanted to revisit this um, pedestrian wind comfort analysis because I made a small but significant mistake in the previous one with one of the numerical values. So I thought it'd be a good chance to revisit it just to describe the process again. So the whole analysis was 40 million cells. So we're dealing with quite a large area. And this is what the result looks like in terms of the wind velocity at height 1.5 meters. So this is quite a large analysis. In order to do the post-processing, we can focus in on a smaller area. So we can choose um, just a region of interest. So we can get rid of all of that. We get rid of all of the buildings and just look at the area of interest. So that's our velocities. And so as I described before, as soon as when you import your velocities, then you do a cell data to point data filter, and then you use a calculator function to get the velocity magnitude, and then you open your programmable filter and you cut and paste all of your Python code into there. And so that's the result that you get. And if we go to view settings, use a background image. I think I was using the wrong legend before as well. So this is the Lawson criteria, which gives the which gives the exceedance probabilities in these different bands. And so this looks a bit different last time because you've got a slightly um, higher probabilities in this area. And the reason for that was because in the script I specified um, the wrong value for the terrain correction. Now the terrain correction is a factor that accounts for the terrain at the weather station and the terrain in your area of interest. Now for this particular case, well previously I used value 0.58, which normally would be correct, but in this particular case the weather station is in the city, which is quite unusual. And so you don't need any terrain correction in this particular case. So I changed that factor to 1, and that does have a significant impact on the results. So it's important that you do check and double check this factor because it literally multiplies the result up by a certain factor. So when I corrected that, then I get um, velocities or exceedance probabilities in the third category, which means business walking. So you've generally got some um, higher velocities around these areas. And like before, I can look at, I mean, the legend will be wrong, but I can look at Davenport. And Davenport has a slightly um, finer scale lower down, so you get more resolution of the exceedance probabilities, the lower ones. So that's Davenport, and there's also Nen. And Nen should also be in the range 0 to 4. So I can just change that. Okay, so that's the Nen, Davenport, and Lawson. So that's all good. And just for reference, this programmable filter script and the other code that I've used for calculating the Weibull parameters, they are all available on my GitHub. So GitHub garcfd Weibull, and you've got the various programmable filter codes that I've used there. Got the Weibull parameters in Fortran, and I've also rewritten Weibull parameters in Python So it does exactly the same thing but in Python. So we've got consistency of using Python code across there. So that's basically it really. I just wanted to do a quick review of that just to make the correction for the terrain factor and to show that the values are a little bit higher than I thought before. Oh, and also this is for a southerly wind, so a wind coming from the south direction, because that is the most likely scenario for this particular New York City location.